Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. Today's problem statement is on finding the maximum depth of binary tree. Okay, we are given a binary tree like this and we have to find out the maximum depth. Maximum depth is the number of nodes in the longest path. Okay, let's jump into the problem statement, start solving. Okay, last time we have solved the middle of the linked list. You can find it as part of the grind 75 list. Okay, let's start solving for maximum depth of binary tree. It's a very simple problem. Since we have solved already a lot of problems on binary tree, it would be really simple for everyone to understand and solve. Okay, let's go through the problem statement. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the furthest leaf node. So if we start from the root node is 3. The furthest leaf node is either 15 or 7. So if we take 15, we can say 1, 2, 3. Total 3 nodes. So maximum depth is 3. If we go 327, it will be 1, 2 and 3. So maximum 3 nodes. It is a very simple, straightforward problem. How we are going to solve it is we are going to check for each node what is the left maximum depth and what is the right maximum depth. That would mean the maximum depth of left subtree and right subtree. Whichever one is maximum, we'll add one extra to it for the current root node, right? And we'll have some base conditions like if the root is null, we can return 0. Or if the left child is null and the right child is null, like in this case of 9, 15 or 7. So for the case of leaf node, if both the children are null, we can simply return 1 because 1 would be the depth of this single node 9, right? So okay, let's start solving and we'll go through it. Okay, so let's have the base case. If the root is null, depth is 0. So we can say if root equal to null, return 0. Simple. Similarly, one more base case. If the root is a leaf node would be like 9, 15 and 7. So the leaf node does not have any children, right? Any child. So the depth is 1. How do we check for the leaf node? We can simply check if root dot left is equal to null and root dot right is equal to null. We can say return 1. Simple. Now we'll recursively calculate the depth of left subtree and depth of right subtree. So we just recursively call the same method. So we can say okay, let's comment it. Recursively find the maximum depth of the left and right subtrees. Okay, you can say int left depth is equal to, we'll call the same method again, max depth, and pass root dot left. Similarly, int right depth is equal to max depth root dot right. Simple. Now at 3 we found out the maximum left depth. So maximum depth of left subtree, that will be 1. Okay, only one node is there, and on the right end it will be 2, either 20, 15 or 27. So 2 nodes in the path. So we'll give the maximum left depth to be 1, maximum right depth will come out as 2, right? Then we need to add 1 to the maximum depth of the 2. So we can simply say, I'll just comment it for everyone, return the maximum depth of the current subtree, add 1 for the current node. you know. So we can say return, and now we'll check using ternary operators. If left depth is greater than right depth, so if left depth is greater than right depth, we will return left depth plus 1, right? Let me put it in brackets. We'll return left depth plus 1. Otherwise, we'll return right depth plus 1. So whichever depth is greater, if left depth is greater, we'll return left depth plus 1 for the current node, otherwise right depth plus 1 for the current node. In our case, right depth is greater, so this one will be returned right depth, which is 2 plus 1, 3. So we'll be returning 3 here, and final answer would be 3 as in this case. Okay, this was a straightforward problem and the time complexity. Okay, guess the time complexity for this problem. Okay, please take time, see what is the time complexity for this problem, and please let me know in the comment section. Let's run it. Okay, it is taking some time. Okay, it's taking some time because of my internet, not because of our runtime. This 0 millisecond beats 100% of the solutions. Great. Okay, that's all from today's video, everyone. Thank you. Please like, share, and subscribe, and don't forget to comment the time complexity in the comment section. Thank you.